Okay, so today we scheduled to present a design meeting, the config architecture. It takes a while for us to converge into this format. So Martin will do the presentation. Before we're doing that, so as usual, if you can go to the meetings, go to the meeting notes and putting your names on the, let me find the meeting notes. Hold on. So config architecture doc is here. Meeting notes. So if you can putting down your attendees and your companies and your names, now we appreciate for this meeting. So now I think Martin sent me the slides.
I'll project actually.
You will project?
Turns out I can't magnify. So.
You can magnify?
I cannot.
Oh, you cannot. Okay, let me present.
No, that's fine. I can present.
You can present, okay.
Eventually.
He might be the Salesforce guy. He's doing the Java control thing work on Salesforce.
Mm-hmm. Yeah, he's actually.
Yeah, I think Salesforce.
Are we recording right now?
Yes, we're recording.
Right, can you guys see my slides?
So I think one of you should mute, please.
I'm muted.
You're muted? How about you? Okay, so that's probably me. Can you hear me?
Yeah.
There's a lot of echo in your room.
Okay.
I'm muted.
What do we do?
Does that work now?
Yeah, I think it worked now.
Can somebody speak so make sure we can hear you guys? Okay, we cannot hear you.
Hello?
I cannot turn off.
So you can't use the all as well as a microphone.
That's what you're supposed to do.
So how about that? Yeah.
So can you go bring that up again?
It doesn't work. So either I pick either one.
Use the meeting hall.
Yes, it's still echoing. Usually the computer.
See my slides?
Yep.
Yes.
Okay. All right, so I think joining the meeting here is a reflection of the effort it took to get to this this design. So this has been going on for several months, where we've been trying to converge on things. We had a summit a few months ago and a never-ending series of meetings. I think we ended up at a pretty good place. So let's get going. All right, so what I'm going to talk about is basically kind of a quick recap of where we are today, the issues we've had, and what we expect to do about it. We'll talk briefly about what the Galley component actually is, how we want to do stage rollout and multi-cluster support, and we'll go through implementation click starts. It's quite possible we won't get to those last slides there, but they're there for consideration. All right, where we are today. Okay, so like everybody knows, customers program Istio through using Kubernetes resources. It provides a pretty flexible and consistent model. It's a nice continuum to just programming Kubernetes itself. So the way we have it now, our resources are targeted at individual components. So the users are actually responsible for understanding how a given particular thing they're trying to achieve, a particular feature, maps to these component level config. And further, users are responsible for ordering an orchestration, how to update these multiple components. So resource updates are in fact dangerous, as it is today. A bad configuration can just lead to a total service outage. There's kind of no warning, you just check it in and it fails, and fails your customers potentially. And excuse me, the emergent state issue relates to the previous bullet about having to orchestrate many updates, having the user to orchestrate many updates. If the user doesn't do this and just says, here's the 3 or 4 resources I want to have, here's the final state of my system, which includes changing these 3 resources. If they're all pushed simultaneously, the system will experience emergent state and kind of unknown operational modes that the operator didn't intend, which will lead to random behaviors, including customer visible outages. It's all temporary because the system will stabilize eventually, but it's transient in nature. Additionally, as it stands today, we have pretty poor diagnosability. We don't use the canonical Kubernetes pattern for reporting resource status. And as I said, individual features sometimes require programming multiple components, and we don't really tell you if the components are misconfigured relative to one another. You just get stuff doesn't work, and you got to figure out why. Another issue is reuse. So in a large mesh that contains 1,000 services, there's a lot of config state that ends up being the same across all these services. And as it is today, we have kind of a mishmash in terms of how we allow reuse of config state across different services within a mesh. So Mixer has this 2-level composition model, which allows a reasonable amount of sharing across services. Pilot is on a different plan, and we just don't have a holistic story there. Which relates to this ACL model. By not having a very clear definition of ownership, who's responsible for who is logically responsible for different kinds of features, it becomes unclear who has the ACL to control the behavior of a service. Is this an attribute of the client of the service, or the producer, or the service producer? It's unclear and inconsistent in our current model. So the distinction between component versus feature-centric configuration is what this is trying to show. Right, so if a user is trying to add a quota to using our nascent API management system, the user is trying to add a quota to be enforced on a given method call. The user is responsible for changing 2 different components. So first, the quota needs to be declared to Mixer, and so a config update needs to be done that is Mixer related. The user needs to wait until that update's actually taken effect, and then can proceed to update the Mixer client, which is in the proxy, so that the quota actually starts getting charged. So that's one case. There are several other interactions that are possible. So in our current model, the user is forced to understand the relationship between Mixer client and Mixer, needs to understand the order. Maybe the order is the same when doing an update as opposed to doing an add. Probably the updates and the orders in reverse if the user is removing things. But it's just kind of exercise left up to the reader. If you do it in the wrong order, you get some outages. Of course, the pattern of just pushing both at the same time, which I said leads to emergent config, well, practice, it probably mostly works. So when you're testing it, it probably just works fine. But in the field, when the system is busy, when it's a large mesh, it might not be fine, and you might have outages that the customer is experiencing as a result of this. All right, so what do we want to do about this? Basically, we want to introduce a pipeline, a transformation pipeline that sits between what the user authors and what the system executes at runtime. So the pipeline has 3 primary phases. One is an authoring step where the user is responsible for composing configuration together to describe the behavior of a service. And we'll talk about those phases in more detail later. The second phase is a transformation phase. So it takes the definition of what a service is supposed to be, compares it to what all other services are supposed to be in the mesh, finds and consolidates, does optimizations, does sharding, and a number of other operations we'll discuss a little later. And finally, the distribution phase is focused on taking the output that was just produced and distributing it to the individual components within the mesh. So in this pipeline, users sit on the left side. They're authoring their config using a composable environment. And on the right side, components are receiving finely tuned configuration that's designed to be easy to parse and understand with very clear semantics. So let's start with the authoring model on the left side of things. So what we're proposing is a scalable model. There's effectively 2 approaches, 2 composable approaches for the user to author config. So first is the direct authoring model. So that's where we introduce the notion of a service config, which we'll talk about a little later. It's a way for the user to describe all the behavior of a service in one place. It's unambiguous. It's complete. If it's not there, it doesn't exist, kind of thing. So it's one place to go to author all the state associated with a particular service. So that's it's great for bootstrapping, great for small meshes. It's easy to understand. Here's my file. It tells me how this service behaves, fully documented kind of experience. It works well. But as a mesh scales, and you have a lot of services, and you have different roles within your organization. So you have security people, and you got operational DevOps people, and you got the service operators. These different parties want to have different roles, different permissions to edit different parts of the config state. You also want to be able to reuse config state across services. So all the services in my mesh, I want them to use the same adapter config to talk to a backend. Or I want them to use a consistent set of labels for in how we manage the traffic routing and so forth. So this composable layer is intended to let the operator compose things together and then produce a service config file that's delivered to the system. So let's look at this graphically. So the architectural input to the system is a service config. It's that single artifact that describes all the behavior of a particular service with respect to the mesh. So we transform this into a component config and deliver this to the individual components running in the mesh. So there'd be a mixer config, and a pilot config, and a broker config, and a CA config. On the left side is the authoring model. So that's a set of small documents that are composed together using tooling in order to produce the service config. So architecturally, service config is what enters Istio. The composable config is outside the realm of Istio and is in external tooling and external systems, as we'll see a bit later. And the final piece of the puzzle is mesh config, which is also kind of blended together with service config to produce the final thing that components consume. So mesh config, I don't talk about it very much in this presentation. It's really intended to capture kind of low-level component control So things like controlling the cache size that an individual component is using, or turning on some debug flags for a particular component, and that kind of stuff. So it's kind of global, and it's whereas service config is strictly in the realm of abstract. Video conferencing system was just rebooting. Whereas service config is kind of dealing with an abstract view of the system, the mesh config actually goes a little lower and is concerned with the kind of physical reality of running code.
Okay,
So,
yeah, Martin, do you want questions and discussion as we go along, or would you prefer to wait until you're sort of finished with the spiel?
I think I'm going pretty quick here, so let's go for questions along the way.
Well, so I had the comment on the document about service config, and I was hoping to discuss it, because I think we're still talking past each other in terms of what's going on there. I think there's a hole in terms of talking about like the totality of the mesh state being expressible in terms of service config and mesh config. That service config is fine for any configuration that we want to attach, or that's I guess the relates to service as a destination, but it doesn't model client behavior very well, because clients may not be in one unique service. They may be not in a service at all, or they may be in multiple services.
So why is the client behavior not controlled by the client's own service config?
I'm saying there isn't a single service that defines the client's configuration, right?
Correct.
The client might be in multiple services.
Yeah. So the target. The idea here is that the service config defines the behavior of the service, the behavior of the mesh relative to service, for anything coming in or leaving that service. So if I'm a client, if service A is a client of service B, this interaction, there's client-side parts of that interaction, and there's server-side parts of that interaction. The configuration for service B is not in any position to state what service A should be doing to it, or how service A should be behaving as it's calling B.
But that's the bit that's where I think we're talking past each other. Is like you're saying service A is calling service B, but in general, like there's no single service A, right? Like I can be in a situation where there is no service that's calling, right? The client is not a service, or the client, it belongs to 5 services.
But when this matters is then you're describing a rule that affects the service, the target service. The target service wants to control the behavior of incoming traffic.
No. I'm saying I as a person who is running the client, I want to control some behavior about how I interact with a different service. Like, just for the sake of argument, let's say that we decide that circuit breaking is a client concern, right? It may not be, or whatever, but just for the sake of argument, let's say it is. So I have a client; it's not in a service. I still want to be able to do circuit breaking when that client calls a remote service.
So as the service provider, you want to enforce that your clients do circuit breaking.
As the service consumer, I want to enforce that when I call service B and I get a certain number of errors, I want to break that connection.
Correct. So isn't that in your configuration state?
But that's what I'm saying, is that my client is not in a service, so where do I put that configuration?
Yeah, I think service config is from the service producer point of view. So the author of service config is the service producer. I think that's the same as all the authentication or authorization model. Like, we care about the incoming traffic. as service producer.
But we also
traffic
wanted-
policies are
yeah,
different from
yeah.
access policies, right? They
Yeah.
have different scope. So I mean, Spike is right in context, right? Clients will need to override networking behaviors in the context of a specific client.
Yeah.
Right. And it's hard to map clients into service definitions. Now, there are scoping things that can be done in Spike, I think, to address the concern here, but they need to be enumerated in the doc. Right? Can a client override aspects of the service config in their context?
No,
Right?
no, but
Information
even beyond that sort of like who's allowed to do what question, like how do I even express it to Istio?
Right, so that has to go in composable config, right? Otherwise, there's no way of expressing it.
So that then it would
Right.
end up that configuration would end up as part of the service config that I'm trying to reach.
So remember that service config is an intermediate artifact of the runtime.
Well,
Right, it's not necessarily the API.
But I mean, if we're going to skip ahead a bit, Martin's going to tell us all that actually the composable configs is an optional piece for large complicated deployments.
Right. So
That service configs and mesh configs are the API.
Right. So in a world where service config is the canonical authoring format, then obviously the client can request that the owner of the service config put the necessary knobs in service config to let them control behavior. Right. That's the model today, for instance, in virtual service. Right. In the revised networking APIs. Right. A shared authoring model.
So isn't that tantamount to saying that there exist no configuration knobs that are owned entirely by the client?
So it is up to the operators to define ownership of service config resources.
So we're saying
no
that service
independent
configs are going to be ACLable, or like we're going to be able to put ACLs at a level below service config?
Okay, a couple. Let me
So
say.
I think Spike, there's a couple of things to point out. One, in the default scenario, right, the service producer will generally own the networking attributes, right? We expect that to be the most common pattern. Two, orthogonal to that, there are ways for people to achieve the access control properties that you want outside of the system, right? They can use code review, for instance. Right? They don't have to use Kubernetes ACL to achieve it. And thirdly, if they want a more sophisticated thing, then they can move to composable configs and have fine-grained ACLs within the deployment system itself. Right? All those three are valid. Do we agree on that?
Sure. Yeah.
So right, at some point, we have to consider what is a reasonable grain of authorship in at least the base API. Right, and that's the approach we took in the revised networking APIs, is to favor the service producer as the canonical owner of all configuration for how the service is talked to. And if a specific client needs different behavior, then it goes into the resource owned by the service producer.
Yeah,
and then people can layer ACLing models on top of it.
Yeah, so that, I guess, if you think of something like configuring the number of retries a client does before, as talking to a server, that's a client concern. Should be expressed in the client's config, I believe.
But that's my point, is that on this diagram, there is no client config. There's service config and there's mesh config.
But isn't the service a client? Like a client?
No, they're not. Right?
Well, if they're not of
Well,
service,
what I'm saying is that clients might not be services, or they may be multiple services.
It's not a
like
service.
in what sense it's not a service? Like a client
A
is
workload,
a service.
no, a client is a workload, is not necessarily a service.
Right.
A service is an exposure concern. A workload is a scheduling concern.
Right, but if that client is not part of a service and is not part of a mesh, how can you even enforce like mesh, Istio related configs?
Ingress, right, is an example of receiving calls from clients that are not modeled in the mesh. You still want to apply networking policies to that.
Okay, so we're talking about the external clients in this case.
That's just one example. I could have things on my physical network that are not external to my network that are also clients.
Right, so how do we do circuit breaking now, or like retries for external clients?
Right, the server side would have to do it.
Well, yeah, but in our case, the ingress is an intermediate. Maybe we can apply a routing rule of the ingress.
Any of the proxies in the mesh would have to do it. And the proxy that's not directly under the client control.
All right, so let's stop the discussion. I think there is some valid points. Let's plan to talk about it. I need a whiteboard to talk about this. So maybe next week we can, or maybe Spike, you and I can just talk specifically and diagram this out.
Yeah.
No, I think that this should be discussed in a wide forum. It is important. It is especially the fact that workflows and services, which I think should be a widely understood concept, is not as widely appreciated. I think we need to address that, and client is just a manifestation of that. So I think we if not right away, we should schedule some proper time for this.
Well,
yeah, that works for me, Mandar.
Okay, we'll do that. All right, let's keep going then.
By the way, there's 11 o'clock. We have a community meeting, and everybody want to attend, so we have 20 more minutes.
Okay. So we're not going to get very far. Okay, so service config, as we've been discussing, the idea there is to have a single document that describes the behavior of a service within the mesh. It is not designed to describe clients of these services, but it is designed to describe how a service interacts. As the service itself is a client, it provides these configurations for the service as a client as well. So, this document is centered around features, not individual components. This approach systematically eliminates, well, the idea here is to systematically decide what's a client-side concern and what's a server-side concern, and organize the configuration accordingly. It also completely eliminates the ordering and eventual emergent state issues that we've explained. So there's only one artifact that describes the behavior service. There's not multiple artifacts that need to be coordinated by the user. The clear ACL model here is to say, look, the service config is in the same namespace as the service. You have access to the service resource. You have access to the service config resource. It's kind of that simple. And the service object, the service config resource provides a clear path toward a meaningful stage rollout model, which we might not get to. All right, the composable config is about about composition. So it's a number of small documents. They're designed to be reusable. So you can share documents across services. You can apply access control to individual documents, but that's largely up to the in our first iterations at least, up to the operator to design this edit and approval workflows in their system. So it's important to note this general approach favors per service control when resources and configuration is introduced into the system. So if you have this global, you want to do a global switch, if everybody's using TLS, in this approach, that global change is done in a composable config somewhere, and somebody needs to run the packager for each service in order to produce the service config file that has this change reflected in it. So that's effectively the pipeline. So there's no instantaneous change to the system. Everything goes through the same rigor of it's a service level change that's rolled out gradually in the cluster. Of course, you can change the rollout semantics to be instantaneous if you have an emergency case, but you still need to run the packager, produce a service config, and then push it. All right, so let's talk briefly about what Galley does. So in this model, Galley is the overall config processor. It's a Kubernetes controller. that ingests the service config resources from Kubernetes. So it performs validation on a number of dimensions relative to service config. So both there's semantic correctness, there's referential integrity checks within the config itself, and there's what I call temporal validation, which is to give you warnings about your change of config over time. So you can be warned that, hey, did you intend to set this quota to 0? Because yesterday you had it set to 1,000, and this might cause outages. All right, so that's validation. Consolidating, optimization, and transforming. So that's about taking all of these service config documents and kind of slicing them horizontally, discovering what's common among them, consolidating in that way, looking at the individual features, and there's cases where you could move functionality and have it done by the proxy and not by mixer, or vice versa, dependent on the configuration of the system. The Galley is also ingests cluster topology information, so it understands the individual cluster, what it looks like, and its scale and dimensions. So that can drive sharding decisions as well. And finally, once the component level config is used, there's a scheduling regime that's how that's the orchestration that Galley does. So for a single change, it might require multiple pushes, components, in order to achieve correct ordering. So that's takes care of this this part here. So the Galley is run in every cluster, and as it says, it consumes cluster topology to drive its decision. So this is a graphical form of what I was describing. Service configs come in, mesh config come in to the API server. Galley validates and allows these configs to enter the system if they're valid. There's a number of transformation steps, and finally, outcomes component configs that are then delivered to the individual components in the mesh. I show a cache here. We'll have to see how things scale as we create this. This might not be necessary, but I expect as a mesh grows very large, at some point you'll want a cache here that can be shared between multiple instances of Galley. So this the right side of the diagram here that shows distribution, we've been talking about different ways to achieve this. There's what I've called here the direct approach, which is effectively having Galley have sockets open to the individual components in the mesh and just doing an RPC call to deliver config. It's very direct, very simple. Doesn't require persisting the component configs, since they're all kind of idempotent creations, direct functions over the service configs. It's not necessary to store them. Unfortunately, however, it has the effect of making these components, programming these components opaque. So it's a private API. The operator can't program those directly. You have to go through the service config transformation. The second approach is a resource-based approach, where each of the components on the right side is actually listening to Kubernetes resources and reads them that way. So the effect is that the component configs in that model become architectural. They become part of our API. They become part of our supported compatibility contract. And it makes it so Galley is no longer the choke point for stuff to enter the system. So the user can go and author these things directly. And then there's a middle ground where maybe the user can't author these things, but at least the user can look at these things for diagnostic. So we need to evaluate which model fits best over time. The second approach is definitely more expensive in computation and in memory load and network load within the cluster, but it provides good access for developers. So that's a thing to debate over the next couple of weeks.
So Martin?
Yes.
There are a couple of kind of technical reasons why direct config might be the preferred, I think the preferred model, at least in the short term. Right. One obvious one being that having an upward API into each of the components facilitates testing.
Yeah.
Right. We don't have to run Galley to be able to right? If Pilot, for instance, had an upward API contract that it could enforce, then any testing driver could just drive that API, and Pilot could be tested in isolation without depending on everything else behind it in the stack being present, which is pretty important property.
Yeah, but
given the complexity of test environments.
But so, okay, so are you saying direct is good?
Yes.
Okay. Well, because it applies to both in reality, what you described. So if you imagine Pilot consuming CRDs as it does today, different CRDs, but still on the CRD plan, we can easily run it in isolation. Well, we can run it in relative isolation. It needs a Kubernetes API server at least.
Right, now that's the point that I'm making. That's already a complex test harness. Right, we already have difficulty with that type of thing. If Pilot had an upward-facing API and didn't read CRDs and there was something else that was responsible for that,
yeah.
Right, most of the functional complexity in Pilot is supposed to be, you give me the information, how am I supposed to serve it, right? That's the thing that it's supposed to do. And the other stuff is really a separate integration concern. And that probably applies in other components too.
Yes, definitely does.
So I got to say, I have a bias for the direct approach because I think it's explicit and it's good for testing, and but the fact that it's not quite as clean of an integration with Kubernetes. Right? There's now opacity in the system. And
well, I don't. If we did a good job with the APIs, that might not really be a problem. In fact, it might be a benefit, right? Going forward.
Well, so that's the thing. I believe that architecturally, I don't want these APIs to be public. It's an implementation detail. The fact that these things have to be separate and they talk over a network and but it's not really what I want in the product.
Well, they're certainly not user facing. I would agree with that. It might be partner facing.
That's fair. So, well, also that's interesting. So even if we expose those as use a direct approach, where they're just basically exposing a gRPC entry point, we could still choose to make that public. So partners can integrate there as well.
Right.
Yeah, so it's we'll have to dive into this in more detail. All right. So I think the last thing I have time to cover is the stage rollout model. So what are we trying to do? So we're going to do a lot of validation up front and have a strong user model to try and capture errors as soon as possible. But hey, bad stuff keeps getting through anyway. So we're just trying to minimize the radius, the blast impact of a bad config entering the system. Right. So you deploy your and in a large mesh with many workload, what do we call it? Yeah, instances of a particular service. You can do stage rollout kind of at the pod level. Shut one pod down, start it up again, and it starts up in the new mode. That's fine for when you have a lot. When you have few, say like 2 pods, then you can have a 50% outage by pushing bad config in that model. So we want to deliver smaller grained rollout, smaller than a pod, and really being traffic driven. So not only can we do selection based on we can select. Well, let me stick to my script here. Get to that in a minute. All right. So the idea here is that we provide the core mechanisms to do this stage rollout, but the operator is still kind of running things from the outside. So the operator tells us what algorithm to use to split traffic between old and new. The operator needs to tell us, okay, I want more users to use it now. I want more users, and they're the ones running that external for loop that drives you to the new model. They're the ones to detect when there's a problem and they need to roll back. I think it's quite likely that we'll be delivering a kind of a full answer to all these questions, or to all these problems. At some point, we'll have an opinion saying, here's a pre-made module to do this. But it's always going to be optional, and the intent is to let the user's existing systems deal with this.
So I think we only have 5 minutes, so I think it's better we stop here. So I think maybe we should run it next week, or I think we should talk about maybe we should arrange a face-to-face on this. What's the next step?
So I think what we let's Well, I'd like to do it sooner. Can we try and just schedule another work group meeting, like Monday or something?
Next Monday?
Yeah.
But I think people want to travel. Come on. If
Oh, well, no, I'd like to finish this. I don't think we need a face-to-face, do we? Yeah.
And so that's my question to people on the VC. So do you prefer a face-to-face?
I think we need to get more feedback into the document. I think we have some pretty high-level feedback. I think, you know, we've already held 2-ish summits. So we should try to make sure that the document grows to meet the needs of developing collective understanding, rather than trying to schedule a whole bunch of people traveling. I know that's difficult for me and a bunch of other folks right now.
Yeah, so my preference would be to do another session like this to finish going through this, encouraging people to do it to update the doc. And I'd like to schedule a separate session with Spike just to discuss this thing, and then we can report back to the group kind of the outcome of that. I think that'd be the best, most efficient use of everybody's time.
All right, so maybe schedule one more session to go through the proposal, and then schedule a separate Q&A session, so that to make sure that, you know, once people have gotten all their comments in the doc, they can be gone through, because it's going to take a bunch of time. Like I have the same. I'm well aware of Spike's concerns. Sriram and I discussed them a lot in the context of the networking APIs. So I'll make sure I get my comments on that vein into the doc.
Okay, so
what would be helpful for me, ignorant as I am, is instead of putting comments in the doc, add a new section at the bottom of the doc with actual explanation and a couple pictures.
Yeah, that's fine.
Maybe
you just want to put a comment in the top of the doc saying, is if you have a detailed high-level comment, maybe write an appendix instead of using doc comments.
Yeah, because it gets
just to guide people.
Open issues section.
Yeah. So so let's just do an open issues section at the bottom.
Okay, so when you guys want to have the follow-up for this, you want to have it sooner or have the next week on the same schedule as today?
I know you'd like to have it sooner, but I think you have to give people a little bit of time here, Mark.
Okay, so let's do it next week, same time. We're gonna schedule an hour. We will finish the doc and the follow-up with Q&A. If we end up not be able to finish, we will go from there.
Yeah, and Spike, I'll contact you for a meeting.
If Spike you can come in, that would be great on the next Thursday.
Yeah. All right, thank you very much.
Okay, thank you. Bye.